Okay, so I am recording this. So for this, we're going to get into natural logs. Natural logs are just logs of base E. So we have actually the same properties we saw for properties of logs in general. So if I go back to here they were. So log base A of 1 and 0, all that. You notice these are going to match up directly with these. So the natural log of 1 is just 0 because e to the 0 power is 1. Natural log of e, since natural log operates in base e, natural log of e is just 1. The natural log of e to any power is just that power. If I do e to the natural log of x, those cancel out, leaving me with just x. And if I say the natural log of x is equal to the natural log of y, then x and y have to be equal to each other. So these are the same just general properties of logs. We looked at them with logs of other bases, base 10, base 5, whatever. This is just natural log is base E. So use a calculator to evaluate the natural log of 10. You are not going to be able to do this very easily by hand, if at all by hand. Honestly, I could give it a quick estimate. It should be 2 point something, just because I know like 2.7 is close to 3. 3 squared is 9. So 10's a little bigger than 9. So I'm just estimating there. So I already got somebody that's saying 2.3. Let's see how that works out. So I'm just going to put in the calculator. I can just go ln, or we could go to the keyboard, go to functions, miscellaneous, and we see ln listed right under here. So ln of 10. Yep. Now, Obadiah had said 2.3. Remember, I like to go about 4 decimal points. So 2.3026 is where I would round it, just to be a little more precise. Just because when we're talking about exponential functions, they grow awfully quickly. So the more precise I am, the better. So I'm going to go 4 decimal places on it, 2.3026. So ln of 10, this was purely in the calculator, 2.3026. That's it. All we had to do was type that in. This work is going to be a little bit calculator heavy, and that's okay. Looking like we're pretty good here. Find the domain of this function. So I'm going to take the time to graph this. Right away, I notice this 3 is inside. If we recall from chapter 1, when we talked about shifting functions, if I put a +3 inside, let's see, since it's plus, that actually goes to the left 3. So I know that my default log has a vertical asymptote at x equals 0. It has a y-intercept at 1, 0. So if I'm going left 3, that gives me a vertical asymptote at -3. That is x equals -3. And I'll also get an x-intercept here at -2, 0. So my default . 2 I'll do in green. This is the ln of x. In blue, this is the ln of x plus 3. So we see all I did was shift everything over, left 3 units. Now, what it's really asking me here is my domain. So my domain, everything is bigger than -3. So my domain is x is greater than -3. And that's it. All I did was shift this over. We will look at that on Desmos in just a second. I do see some people writing, so I want to make sure they got the time to get this down. So yeah, let's take a look at the graph. If I do the ln of x, it defaults to this here. Notice that y-intercept here. I had that nice vertical asymptote. But if I put in the ln of x plus 3, we notice this blue graph, again, getting shifted over, has this nice x-intercept of -2, 0. And if I draw this vertical asymptote of x equals -3, again, that vertical asymptote lines up how we want it to. So again, I always like to do my asymptotes as dashed lines to make them very obvious that they're an asymptote, not part of the graph, or not part of the values of the graph. Any questions on that? Okay, now this is an example of some real life uses of natural logs. So a principal P invested at 6% interest and compounded continuously increases to an amount K times the original after T years, where T is given by this. So this is a very interesting formula here. Basically, if I want to try and double my money, this can tell me how long that will take at this interest rate. So I can just plug in 2 for K and divide by whatever interest you have. I can also plug 3 in and do the same thing. Now, this is an interesting application of exponentials. It might not be what you feel is of logarithms. One of the more interesting ones, a lot of the math dealing with the idea of the pH scale actually deals with logarithms and things of that nature. So for this, if I want to double my investment, if I'm able to earn 6% interest, I could just use this simple formula to tell me how long it's going to take to double my money. So all I'm going to do is put that in the calculator. So that's the ln of 2 divided by 0.06. And it will take about 11.5 years. With this one, if you only want to go 1 decimal place on it, that's fine. And I'm saying that's fine for this because we're talking about time here. If I told you something took 11.5 years versus 11.5 5 years, you'd be like, that's pretty much the same thing. We're just talking about a few days difference there. So I'm going to say 1 decimal place is fine. So that would be approximately 11.5 years. Now, to triple the money, we could just put 3 in to the natural log. So the natural log of 3 over 0.06, our interest rate. So let's see, to triple my money, how long will that take? Divided by 0.06. So if I want to triple my money, that's going to take about 18.3 years. So not too bad. You know, if I gave 6% interest, if I'm told, like if I put $10,000 in an account, let it sit for 18 years, and all of a sudden I have 30,000, I'm not going to be too unhappy about that. Not too unhappy about that at all. In fact, I'd love to get 6% interest on things, but unfortunately, many banks are not offering interest rates that high currently. So that was 18.3 years approximately. So that is our last example for these notes. What I'm going to ask you now to do is to try and get started. I initially listed this as classwork/homework because when I did this previous, the same thing happened. This lesson's a little bit shorter, coming around the second time, just adding E into it. So I'm giving you time to work now. We're doing 77 through 88 all. I know that seems like a few problems, but some of them are just plug in numbers. Use the calculator. It's not that hard. And then we're doing 94 through 98 even. So we're just going to take the rest of the class to get started with that. Thank you guys for being here. I'm going to stop the recording.